Ever wondered if AI could help us solve complex problems in ways we never imagined? Today, we're diving into a groundbreaking study that asks, can AI models like ChatGPT or Claude help researchers build better decision-making tools? Spoiler, the answer is a mix of wow, really. But not quite yet. Let's start with the basics. Imagine you're trying to figure out why people choose a bus over a car, or why a customer picks one product over another. That's where discrete choice modeling comes in. It's like a puzzle. Researchers use it to predict human behavior based on factors like cost, time, or personal preferences. But here's the catch. Building these models is like solving a Rubik's Cube while blindfolded. It takes years of training, a ton of data, and a deep understanding of statistics. Now enter AI. Specifically, large language models, the same tech that powers chatbots and virtual assistants. These models can write essays, code, or even solve math problems. But can they help build decision-making models? The study says maybe. Here is how they tested it. Researchers gave 13 versions of 6 major AI models, like GPT, Claude, and Llama, simple tasks. For example, they asked the AI to suggest a model for predicting transportation choices. But here's the twist. They used 2 different prompting strategies. The first was zero shot, like asking a friend for advice without giving them any context. Hey, what's the best way to predict choices? The second was chain of thought, guiding the AI step by step, like a teacher explaining a math problem. First, identify variables. Next, check for interactions. Then, validate the results. And the results. Some models shined. For instance, Claude 4 Sonnet created the most accurate and complex models when given a simple data summary. But others, let's just say they struggled. Open-source models like Llama and Llama couldn't even finish the task. Meanwhile, proprietary models like GPT 3.5 delivered stable, reliable answers, though none were perfect. But here's the kicker. Limiting data access sometimes improved performance. That's wild. It suggests AI models might be relying more on internal logic than brute force data analysis. But open-source models still lagged, highlighting a gap in their ability to handle complex tasks. So what does this mean? These models aren't a magic solution, but they're a game changer. They could save researchers hours of work, reduce errors, and even spark new ideas. But they're not a replacement for human expertise, yet. This study opens a door to a future where AI and humans collaborate. As these models evolve, their role in fields like economics, psychology, and urban planning could explode. But for now, it's a fascinating glimpse into how machines are learning to think, and how we might learn from them. Now, let's dig deeper into the technical weeds. How do researchers actually measure whether an AI model is good at building decision-making tools? The answer lies in metrics like log likelihood, AIC, and BIC, 3 statistical tools that reveal how well a model balances accuracy and complexity. Take log likelihood, for example. It's like a puzzle solver checking if all the pieces fit. In one experiment, GPT 4.5 nailed it with the best score. But then came the twist. Claude 4 Sonnet crushed it in another test by using a structured thinking prompt, like giving the model a step-by-step roadmap. The result? The lowest log likelihood score, meaning it squeezed the most insight from the data. Here's where it gets weird. GPT 4.0 and 3 other models actually performed better when given less data. That's counterintuitive. It's like asking a chef to cook a meal with fewer ingredients. Sometimes, simplicity forces creativity. The theory? Too much data might overwhelm the model, making it fixate on tiny details instead of the big picture. Now let's talk about AIC and BIC, 2 secret weapons in the researcher's toolkit. These metrics balance how well a model fits the data and how simple it is. Why does simplicity matter? Imagine a detective solving a crime. Too many suspects equals confusion. The same goes for AI. In this study, Claude models dominated. Specifically, Claude 4 Opus had the lowest AIC score in the limited data test, proving it's the gold standard for balancing accuracy and efficiency. Even cooler, the same 4 models, including GPT 4.0 and DeepSeek, hit their peak performance when given less information. But here's the kicker. When researchers cranked up the complexity with BIC, which penalizes models even harder for being too fancy, Claude 4 Opus still led the pack. Meanwhile, GPT 4.5 shone in a different experiment, showing that structured prompts, like step-by-step reasoning, can guide models to smarter solutions. It's like giving a student a cheat sheet for a tough exam. Sometimes, the right framework makes all the difference. So what does this mean for the AI world? It's not just about having the biggest model or the most data. It's about how you train them, what you ask them to do, and when to let them think deeply versus rely on brute force. And right now, Claude seems to have the edge in striking that perfect balance. But here's the real takeaway. AI isn't a silver bullet. It's a tool, one that requires human oversight, creativity, and a deep understanding of the problem at hand. The future isn't about replacing researchers with machines. It's about empowering them with tools that can handle the tedious, the repetitive, and the data-heavy, so they can focus on what they do best, asking the big questions. If you found this intriguing, hit subscribe for more deep dives into cutting-edge science and tech. And let me know in the comments, do you think AI could one day replace human researchers? Or will our unique creativity always be irreplaceable? Let's discuss. Thanks for watching. If you want to stay in the loop on the latest AI breakthroughs, hit that subscribe button. And remember, technology isn't just about what machines can do. It's about what we can achieve when we work together. Until next time,